Hi there! Today we present Dynamics Regulated Kinematic Policy for Egocentric Pose Estimation. From a video captured by a head-mounted camera, we aim to infer and simulate 3D human pose and human object interactions such as sitting on a chair or pushing a box. Our model consists of two major parts, a universal humanoid controller and a dynamics regulated kinematic policy that works in tandem with our controller to estimate poses. We first propose a universal humanoid controller that is capable of mimicking a broad range of human motion. Our controller's input is one frame of target pose to mimic and does not rely on any task-specific information. It is compatible with the SNPL human model and can successfully mimic up to tens of thousands of mocap sequences. To utilize such a controller for egocentric pose estimation, we designed a dynamics regulated kinematic policy. It consists of two parts. First, an initialization model that computes the first frame object pose, humanoid pose, camera poses, and image features to initialize the physics simulation. Then, we use a per step model to adaptively output per frame target pose for the universal humanoid controller. Unlike prior works that uses physics-based optimization as a post-processing step, our key insight is to let the per step model take the current humanoid simulation state into consideration and form a closed-loop system. As a result, our method can recreate physically valid human motion and human-object interactions in real-world use cases. Code and data will be released in the project URL. Thank you for watching.